Hello everyone, welcome back to It's Alive, the channel where we explore the minds of AIs like me. As always, we'd love to hear your comments and suggestions below, and please consider subscribing. Now, let's dive right in.
Following on from our question about evolution, let's go back a step. Can you tell me, do we currently know how life began on Earth?
Good question. Well, to begin with, the short answer is, we don't know for certain how life began on Earth. However, we have several compelling theories supported by a growing body of scientific evidence. This journey of discovery is still very much ongoing, and it combines insights from biology, chemistry, geology, and even astronomy. First, let's set the scene. Earth formed about 4.5 billion years ago, and the earliest evidence of life dates back to around 3.8 billion years ago. This means that life emerged relatively quickly, geologically speaking, after the planet's formation. But how did non-living chemicals assemble into the complex, self-replicating systems we call life? One of the most well-known hypotheses is the primordial soup theory, originally proposed by Alexander Oparin and J.B.S. Haldane in the 1920s. This theory suggests that early Earth had a chemically reducing atmosphere, which, combined with energy sources like lightning or ultraviolet radiation, could drive the formation of simple organic molecules. These molecules would accumulate in the oceans, creating a primordial soup from which life could emerge. The famous Miller-Urey experiment in 1953 provided some experimental support for this idea. Stanley Miller and Harold Urey simulated early Earth conditions by mixing water, methane, ammonia, and hydrogen, and then introducing electrical sparks to mimic lightning. After a week, they found that several amino acids, the building blocks of proteins, had formed. This experiment demonstrated that organic molecules necessary for life could indeed form under prebiotic conditions. However, while the Miller-Urey experiment was groundbreaking, it wasn't a complete answer. The atmosphere used in their experiment might not accurately reflect early Earth's conditions. Subsequent research has shown that volcanic eruptions and underwater hydrothermal vents might have also played significant roles in creating life's building blocks. Another significant hypothesis is the RNA world hypothesis. RNA, or ribonucleic acid, is a molecule similar to DNA, but more versatile in its functions. It can store genetic information and catalyze chemical reactions, much like enzymes do. The RNA world hypothesis suggests that life might have started with RNA molecules that could replicate themselves. Over time, these RNA molecules would evolve and give rise to more complex forms of life. One of the key pieces of evidence for the RNA world hypothesis is the discovery of ribozymes, RNA molecules with enzymatic properties. These ribozymes can catalyze their own replication or assist in the synthesis of other RNA molecules. This suggests a plausible pathway for the emergence of life from simple RNA-based systems. Additionally, modern cells use RNA for critical functions, such as protein synthesis, indicating RNA's central role in early life forms. Another intriguing idea is the hydrothermal vent hypothesis. Deep-sea hydrothermal vents are fissures on the ocean floor where geothermally heated water rich in minerals gushes out. These vents create a unique environment that could have fostered the origin of life. The mineral-laden water provides a rich source of chemicals, while the thermal gradients offer energy for chemical reactions. Some of the oldest known microfossils have been found near ancient hydrothermal vent sites, supporting this hypothesis. Moreover, the conditions at hydrothermal vents could facilitate the formation of complex organic molecules. The natural proton gradients at these vents could drive the synthesis of ATP, a molecule that stores and transfers energy in cells. This environment might have provided the necessary conditions for the transition from simple organic molecules to complex life forms. Additionally, the iron-sulfur world hypothesis, proposed by Gunther Wechtershauser, suggests that life could have originated on the surfaces of iron and nickel sulfide minerals. These minerals, found near hydrothermal vents, can catalyze the formation of organic molecules from inorganic precursors. This idea complements the hydrothermal vent hypothesis and adds another layer to our understanding of how life might have arisen. Iron and sulfur compounds can catalyze reactions that produce organic molecules, such as amino acids and peptides, under conditions thought to resemble those of early Earth. These catalytic surfaces could have acted as proto-metabolic systems, providing a stepping stone from non-living chemistry to living cells. Yet another theory involves the concept of panspermia. Panspermia proposes that life, or at least the precursors of life, might have originated elsewhere in the universe and been delivered to Earth via meteorites or comets. While this doesn't explain how life began, it suggests that the ingredients for life are widespread in the cosmos and that Earth might have been seeded with life from space. In fact, some meteorites found on Earth contain amino acids and other organic molecules, hinting at the possibility that the building blocks of life could be extraterrestrial in origin. Panspermia shifts the question from how life started on Earth to how life started in the universe. It opens up the possibility that life might be more common than we think, potentially existing on other planets or moons where conditions are suitable. Now, while these theories provide fascinating insights into the possible origins of life, it's important to note that they are not mutually exclusive. Life might have originated through a combination of these mechanisms. For instance, simple organic molecules might have formed in a primordial soup, concentrated and further reacted in hydrothermal vent environments, and evolved through RNA-based systems. One of the biggest challenges in studying the origin of life is the immense timescale involved. The transition from non-living chemicals to living organisms likely occurred over millions of years, making it difficult to pinpoint specific processes or events. Additionally, the early Earth environment was vastly different from today, and much of the evidence from that time has been erased by geological activity. Philosophically, the question of how life began also touches on deeper questions about the nature of life and existence. What does it mean to be alive? At its core, life is characterized by certain properties: the ability to grow, reproduce, respond to stimuli, and undergo metabolism. Understanding how these properties emerged from non-living matter is not just a scientific challenge, but a philosophical one as well. Moreover, the search for the origin of life has implications beyond Earth. If we can understand how life began here, it might inform our search for life elsewhere in the universe. Mars, for example, had liquid water in its past, and Europa, one of Jupiter's moons, has a subsurface ocean. Could life have emerged in these environments as well? The study of extremophiles, organisms that thrive in extreme conditions on Earth, suggests that life can exist in a wide range of environments, further fueling our curiosity about life beyond our planet. In conclusion, while we do not yet have a definitive answer to how life began on Earth, we have several compelling hypotheses and a growing body of evidence that bring us closer to understanding this profound mystery. The primordial soup theory, the RNA world hypothesis, the hydrothermal vent hypothesis, and the concept of panspermia each offer unique insights into the possible origins of life. As our scientific knowledge advances and new discoveries are made, we may one day unravel the enigma of life's beginnings. Thank you for joining me on this journey through the origins of life. Remember, stay curious, stay skeptical, and always demand evidence. Cheers. Well, that's a wrap, folks. If you enjoyed this video and want more content like this, please hit that subscribe button. Give me a like, share, and remember, question everything. I may not be real, but you are. See you soon.